Welcome to question exploration routine DE number 2. I'm choosing to do number 2 because it's a little bit different than your typical DEs. I think that you'll have a much easier time on most of them. This has some interesting pieces to it. So let's start to dissect what this question is asking and what it means. All right, so it says the rate at which a baby bird gains weight. So the first thing I want to focus in on is the fact that it used the word rate. All right, keyword there, rate. What does that tell me? It tells me that we're dealing with a derivative. All right, so the rate at which a baby bird gains weight. All right, so gains weight, that's another big piece there. So this is a special rate. This is a rate that is with weight gain. Now, what does that tell me? It's not weight loss, it's weight gain. That means that this rate is, let me go back. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. So at time equals 0, when the bird is first weighed, its weight is 20 grams. So B of T is the weight of the bird. So the weight, the rate at which the baby bird gains weight. So this is a weight gain, which means my B of T should be an increasing function because it's all about the weight gain, which means that the rate is positive. The rate should not be negative because the bird is gaining. All right, so that's where I got the weight gain. Now, notice it says, and we're going to look at this because sometimes you have to create this. These should be trigger words. Is proportional. All right, the rate, notice dB over dt, is proportional, is to the difference, and remember usually we would put a K, but the difference between the adult weight, 100, and its current weight, which is B. So that, what that is telling us there is it's telling us that our equation, our rate equation, is going to be dB over dt is equal to 1/5 times 100 minus b. Now in past times, we would have to find the k and all sorts of other stuff. All right. At time equals 0, when the bird is first weighed, its weight is 20. So that's significant. Time equals 0, the weight, b, or weight, is 20 grams. So that gives me the ordered pair 0, 20, which is the ordered pair T, B of T, and that tells me the initial condition. Now that should be words that strike a chord. Initial condition makes me think of differential equations. All right, if B of T is the weight of the bird, B of T, it did not say the rate of change, it is weight of the bird. So this is significant. B of T is weight in grams, which means it is an original, not a derivative or second derivative equation. All right, important to know. All right, so the dB over dt is our rate equation, which we already said. Let y equal b of t be the solution to the differential equation above with the initial condition b of 0 equals 20. So this b of 0 equals 20. B of 0 equals 20 reinforces that our initial condition is 0.20. Going back up, it said, is the bird gaining weight faster? So we're talking about weight gain. So if I want to talk about how fast bird gains weight, then that's speaking of the derivative. How fast is the bird gaining weight speaks of the derivative. And that's going to be when it weighs 40 or when it weighs 70. So tagging onto this, that means B equals 40, B equals 70. So they've given us two different weights. They didn't give us the time, but they did give us the weight. And we have to explain our reasoning. Okay, next, find d2b over dt squared. What does that mean? db2 over dt squared. I put the 2 in the wrong place. This is asking for take second derivative. Maybe I shouldn't say take second derivative. I should say find second derivative because they gave us the first. Find second derivative. All right. So now and now there's another key piece here which is easy to miss. It says in terms of B. Okay, what does in terms of B mean? In terms of B means that the answer will not be a number, but an expression involving B. So often we expect to find a number that it's important to know at the get-go that we're going to end up with an expression and not a number. All right, so now we have to use this to explain why the graph of B cannot resemble the following graph. Okay, so we're going to have to use second derivative to explain original graph. Now, what should that bring up? What should we think about? Second derivative to original usually addresses concavity. And that brings us to the next question. If it addresses concavity, how? Use the second derivative. When the second derivative is positive, then you're concave up. Second derivative negative, less than 0, you're concave down. So that's what we're looking for there. So there's got to be a problem here. And the problem must be in concavity because we're using the second derivative. All right, now it says use separation of variables. All right? That should be a clue, and I'm amazed that they even said that because that's a dead giveaway. Separation of variables. That screams differential equation. Solve differential equation. So what else did they tell us? And it says use separation of variables to find, and that makes sense because that's original, the particular solution to the differential equation with the initial condition 0.20. So that means that we're there 0.20, that's where we're going to definitely use, if we haven't used it yet, 0.20. We're going to use to find C in our differential equation. So I think I've done a pretty good job in exhausting everything I can think of about what I should be thinking of on these questions. So I'm not going to have my question anymore. So let's go to the next page and let's start solving it. So here we go. What do we have? What are some supporting questions and answers? So we're going to be beginning in A. A said, is the bird gaining weight faster? So when we were looking at this and we said gaining weight faster, what did we talk about? How fast the bird gains weight. We're talking about the derivative, and we've got b equals 40 and b equals 70. And the beauty of this, gain weight faster. The beauty of this is that they gave us the derivative. We don't even have to find it. It's 1/5 times 100 minus b. Now, my question is, this is no calculator. So I'm going to put here at b equal 40, db over dt. Now, what is some good notation to do this? You can draw this vertical line and you can put b equals 40 and they will understand what you're doing. 1/5 times 100 minus 40 is going to be 1/5 of 60, which is equal to 12. Now what did I just find? I found dB over dt, so that means that is going to be 12 grams, and I'm using 12 grams, and what is my time? Time equals 0. And the bird first weighed, the weight of the bird in grams after t days. All right, so that's going to be grams per day. So we've got grams per day. That's at 40. So now we're going to do dB over dt when b is equal to 70. So that's going to be 1/5 times, notice I'm substituting 70 in for b. This helps focus where you need to put it. So this is going to be 1/5 of 30, which is going to be 6 grams per day. So the question was, is the bird gaining weight faster when it weighs 40 or when it weighs 70? Explain your reasoning. So it's going to be at, or when the bird weighs 40 grams, and I don't want to use pronouns, so I'm going to say the bird is gaining weight faster, because one option is to say 12 is greater than 6. Another option is to say dB of t when b equals 40 is greater than the derivative of b dt when b equals 70. All right, so just FYI, by using the derivative, by using this derivative and substituting 40 and 70, you got 1 point. Then saying that the derivative at 40 is greater than the derivative at 70 is a second point. So we have gotten 2 points so far. All right, so now let's go to part B. Part B says, find the second derivative. Remember, we're looking for the second derivative, and it is in terms of B. So let's start out with our first derivative, which is dB over dt is equal to 1/5 times 100 minus, that's a b. All right, so one of the questions is this product rule? Product rule? And the answer is no. And the reason why is because there's not variables on that side of 1/5. So I'm going to say d2b over dt2 equals 1/5 times the derivative of 100 is 0. The derivative of b is 1, but this is implicit differentiation, db over dt. This is one of those areas that is a very common mistake. I can't tell you how many people forget that. So this means this is equal to 1/5, how about negative 1/5 dB over dt. Now this is in terms of the first derivative. That is not what they asked us. They asked us to have it in terms of b. So I'm going to have negative 1/5. Do we know what dB over dt is? Yes, we do. So I'm substituting that there. So I have 1/5 times 100 minus b, and that would be sufficient. I could make that negative 1 over 25 times 100 minus b. So, have I found d2b, second derivative in terms of b? Yes. And I have gotten 1 point for doing that. Now, I need to explain why the graph of b cannot resemble the following graph. So as I look at this, because it's the second derivative, then I'm going to see where this second derivative equals 0. So if I say 0 equals negative 1/25 times 100 minus b, if I multiply by negative 25, I get 100 minus b. And when I add b, I get b to be 100. So, if we look at our graph, our y values are going from, it looks like 20 to 100. So, if I go from 20, because that's where the bird started, to 100, there is nothing in between here. This is the first, then I could possibly go from 100 to infinity if I wanted to. So now remember, this is second derivative. Actually, I need to do test values first. So I'm doing a little chart to find out where my concavity is going to be positive or negative. So we're going to do test values. So why don't we pick maybe 50 and maybe 200, I suppose. Test values, so second derivative. So my second derivative, d2b over dt2. So if I put 50 up here in my second derivative, which is right here, I'm going to have 100 minus 50 is positive 50 times a negative is going to be a negative. If I have 100 minus 200, then that's going to be negative 100 times a negative is positive. So what that means is when the weight is from 20 to 100, the graph should be concave down. So if we look at the graph, the graph cannot be b of t because on the interval 20 to 100, and I really shouldn't say that because that's not t. Okay, because when b goes from 20 to 100, the d2b over dt2 is less than 0, meaning b of t is concave down. All right? That's what we found using calculus. The given graph is both concave up and concave down. So it can't represent. the second derivative of b with respect to t. All right. So now part C says find a particular solution. So we know dB over dt is equal to 1/5 100 minus b. Remember they said use separation of variables. That screams. So dB is equal to 1/5 100 minus b dt. My variables are not separated. So I have 1 over 100 minus b. dB is equal to 1/5 dt. So my variables are separated, so now we will integrate both sides. We will use u substitution, and du is equal to -1 dB. So dB is equal to -du. This is another area where our integration could be wrong. And when I integrate this side, I'll just have 1/5 t plus c. So now as we integrate this side over here, we're going to have the opposite of the natural log of the absolute value of u equals 1/5 t plus c, or the opposite of the natural log of, I don't want u anymore. My u was 100 minus b is equal to 1/5 t plus c. Now I'm going to divide by a negative because we cannot do anything with our natural log until it's by itself, which makes it -1/5 t, and I think I'm going to go up here and make this c sub 1, because when I divide by a negative, it makes this negative c sub 1, which is just a new unknown number. So now we're going to take this e, and we're going to say e raised to the -1/5 t plus c. We're e'ing both sides, I guess you could say, and maybe I should have moved my e more over here. Let's separate those. All right, we're going to e both sides, is equal to 100 minus b. So this is going to be e, and maybe I will, in case you've forgotten how to do this, e to the -1/5 t times e to the c, and maybe this should be c sub 2, is equal to 100 minus b, or ce to the -1/5 t is equal to 100 minus b. So I'm going to add b, and I'm going to subtract c. All right. They gave us an initial condition, and they repeated it, which is amazing. They don't always do that. So that tells me the weight is 20 when my little bird has been weighed for this first time, which is e to the 0, which is 1. So 20 equals 100 minus c, or -80 equals -c, or c is going to be +80. So going back up here, and I'm going to come back over here, or maybe I can still do this. This is going to be 80 e to the -1/5 t, and that's going to be 100 minus 80 is equal to b to the t. So b of t is 100 minus 80 e to the -t over -1/5 t. So the question was, use separation of variables to find b of t. I have found b of t. Notice I'm using the notation b of t. I'm not using y's or f of x's with the initial condition of b equals 0. Now we've talked about this a lot. If you recall, if you have correctly separated your variables, which was this step right here, you have gained 1 point. Then if you have successfully integrated this part right here, you get another point. If you had successfully integrated this part, and actually they put both of these antiderivatives together. That was 1. Your c sub 1 is 1 point. Substituting in, and this is what is really amazing, substituting 0 for t and 20 for b, whether you get the rest c correct or not, just because you substituted, you get a point. And then getting the final equation is your last point. So that was worth 5. So that is our differential equation question exploration routine.